Welcome to the compressed heat exchanger demonstration. Today I'm going to go over some of the features that are available to you in Compress and how we design heat exchangers. So let's get started. Here's a typical heat exchanger that I had modeled in Compress. So this is our fixed exchanger. We have a bellows expansion joint on it. And we can take a look inside this exchanger too. So we click on the Show Internals button. You can see we'll also represent the tube sheet and the tube bundle for you, and you can see some baffles there. But how do we go about designing this heat exchanger? With the heat exchanger module in Compress, we set up everything in what we call a wizard. And what this does is it's a large dialog that contains all of the information for the heat exchanger. The benefit of doing it like this is that instead of having to model things component by component, we can simply just enter in all of the design data, let's say from a TEMA spec sheet or a client spec sheet, and we'll model the heat exchanger for you. So why don't we go ahead and model this exchanger? So what I'm going to do is come up to the File menu, select New, and we're going to select Heat Exchanger. So this will open up our heat exchanger dialog, and then we can start filling out the information. So what we'll do in the heat exchanger is we'll first ask you for general configuration, and this is on our generals options page that you'll see in front of you. So for example, the exchanger type, well, we'd like to design a fixed or stationary tube sheet, we'd like to do a U-tube, or even a floating tube sheet. Then we ask you for the calculation method. Compress can design exchangers using the TEMA rules, the ASME rules, or both. Then we have a few other options for the ASME, such as our shell bands present, would you like to use the operating temperatures, things like that. For the TEMA rules, you can choose which edition you'd like to use, whether you'd like to use the 7th edition, the 8th edition, or the 9th edition, and then the TEMA class. And then if there's going to be an expansion joint present. From here, we ask you the type of shell that we're going to be designing. So this is going to be a 1-pass shell, a 2-pass, split flow, things like that. Now the other item that we have on this dialog is our heat exchanger defaults. What we can do is set up defaults files so that once we enter in our heat exchanger, we can save all these inputs. And this is very handy if you're doing or you're building the same type of unit. So for example, if your company specializes in 3 different sizes of units, well, you can save, let's say, the 60-inch unit, the 90-inch unit, and maybe the 120-inch unit. So if a client calls and says, I need a 60-inch unit, we can load this defaults file in, and we can make any slight changes we may need to. So what you would do is just simply select the defaults file here, and when you save it, you just simply go and look it up like so. So I'll load in the heat exchanger demo, click open, and it'll get loaded. Now you can also create a new defaults file, so if this is a new exchanger, you can save all these inputs as you're going along and then save them afterwards as well. Okay, so this page is set right now, and I've loaded in my heat exchanger demo defaults. So what I'm going to do is click next. Now the first few pages for the heat exchanger dialog are going to be for the design conditions. We're going to look at the tube side design conditions, then we're going to look at the shell side design conditions, the tube sheet design conditions, and then some bellows joint conditions, and then liquid levels. So for the tube side design conditions, we can set up multiple conditions. So for example, I've got 4 set up here. I have the operating condition, the startup condition, the shutdown, and the upset. And these are what I set up. So you can name them anything you want. And then based on this, we just go through some very basic inputs. So for example, the internal design pressure, the internal design temperature, the external design pressure, and then the operating pressure. And we would do this for each one of our conditions. Then we're going to select the materials for the tube side components. So for example, we have the tube right here. We just look the material up from the pull down list and you select the tube that you'd like to use. From here, we'll just need to know the tube mean metal temperature for each of the conditions. And if you'd like to see some material properties, you can click on the Show Material Properties button right here, and you can see where Compress is pulling a lot of the information from, for example, the thermal expansion coefficient source, the yield stress source, things like that. But I'm just going to hide this. And then we're going to do the same thing for the channel cylinder. So again, from the pull down menu, we're just going to select the material that we're going to build the channel out of. So what I'm going to do is I'm going to click next. And then we're going to do the same thing for the shell side conditions as well. So for example, we have our operating, startup, shutdown, upset condition. We just need to enter in the pressure and temperatures, external design pressure and the operating pressure, and then select the material and the shell mean metal temperature. So again, I'll click next here. Then we come to the tube sheets page. Now, since we've already set up the shell side and the tube side design conditions, we already know what pressure and temperature is acting on either side. So really with the tube sheet, we just need to know the material, like so, and then the mean metal temperature as well. So again, from here I'll just click next. And because I have a bellows expansion joint set up in this defaults file, we'll ask you for the design conditions for this as well. Mainly we're going to ask you for the material. Alright, I'll click next. Then we can specify a liquid level acting on our heat exchanger. Why is this important? Well, compress will automatically account for the static head that might be acting on the tube sheet. And this is part of the code requirements. We need to consider all loadings acting on the tube sheet. So if there is a liquid level, we can specify it here. Okay, so far we've set up our design conditions. So now compress has everything you need to start selecting sizes for you. So the next few pages are going to be the component portion of the heat exchanger. So I'll click next. And we're going to start with the tube geometry, the shell, and then any baffles. So the first thing we're going to do is we're going to look at the tube geometry. So what we'll need to know is the length between the outer tube sheets. So essentially the overall length of your tube bundle. So we'll just leave it at 120 inches. And then we need to select the tube diameter and the wall thickness. Now you can type in this information if you'd like, or we can select a tube from here. And we can look up, the specific size that we'd like to use and click OK. Now one thing you may notice here is that beside the wall thickness input, there's a black text. Well, what does this mean? This is a calculated minimum. So as we're designing our heat exchanger, we're constantly running calculations for you in the background. So based on all the inputs we have so far, this is the minimum tube wall thickness that we need to account for. And keep in mind there's also going to be a tube mill tolerance applied to this as well. Alright, from here we just need to know the tube expansion depth ratio. Type that in, and then we can move on to the next component, which in our case is going to be the shell. So again, just type in the inner diameter you have and the thickness. We'll tell you what the minimum needs to be, if there's any corrosion on the inside or outside of the shell, and then the MDMT. Now this MDMT input is a target MDMT, so this is what we're trying to design to. More than likely this might actually be able to go a lot lower than 0 degrees, but if it's not, let's say it's only good to 10 degrees, we're going to warn you in the report. Alright, then the last thing we're going to do here is we're going to specify baffles. Now you can do this in two ways. If you know where the baffles are laid out now, we can enter in the information. But if you don't, what you could do is just take the baffles out for the time being, get the rest of the heat exchanger set, and then come back in and add them. But again, if there's our baffles present, we just activate this option. You can have compress automatically place the baffles for you, or you can turn this off and you can manually space them where you'd like them on the heat exchanger. Okay, so the tubes and shell page is done right now. So what I'll do is I'll click next. And then we come to the channel page. So this is where we're going to look at the front and the rear channel. So up at the top here, we have to decide, well, what type of channel are we going to use? We can do a channel type, which would encompass a bolted cover or a welded cover. If you decide to go with a bolted cover, we can design the flanges using the Appendix 2 rules, or we can look up a B16.5 flange for you. We can also do a reducer and then a bonnet type. Now the front channel is currently set up with a bonnet type, and I have an ellipsoidal head being used, but I can also use an F&D head or a hemispherical head. From here, we just need to know the geometry of the head itself. So first thing is the material, and then the diameter, the minimum thickness, straight flange length, things like that. And then again, we'll do the same thing for the channel cylinder. Once you get this set, we'll switch over to the rear. Now if you have bonnets on both sides, you could actually copy the front end properties so you don't need to type the information in again. But I chose to set this up as a bolted cover, and I've got an Appendix 2 flange on this. So once we get this all set, what we can do is click next. And then we come to our expansion joint page. In the expansion joint page, we'll just need to know the geometry of the expansion joint. And then we can just type this information in the inputs here. So again, I'll click next. And then we come to the tube sheets page. So what we do here is, like I said, we're running through all the calculations. So based on all the previous information we've entered, this all factors into the tube sheet thickness. So what we'll do here is we'll fill out the remaining information. So the tube layout pattern, You know, is it going to be a 30-degree triangular layout, 45-degree square, 60-degree, or 90-degree? I'll just leave it at 45. And then we'll look at the tube-related inputs. So how many tubes do we have in this exchanger? What's the tube pitch? How many tube passes are there? Well, we have a pass partition in here. And then the radius to outermost tube center. Based on all of this, we're going to run through and we're going to tell you what the thickness is to the ASME rules as well as TEMA. So you can see the ASME rules is a bit lower than the TEMA, but they're really, really close. So what we're going to do is we're going to say the thickness here is 1 3/8 like so. Then from here, we can fill out any other information we may have. For example, some material options. You know, is the tube sheet going to be normalized? Will it be produced to fine grain practice? Will it be impact tested or even post-weld heat treated? We can then choose if we want to make the shell side integral or gasketed, and the same with the tube side. So if you would like to have a gasketed configuration, so it's flanged on both ends, you could select that, and we could look up the flanges for you. Likewise, we can also specify step tube sheet. So if you've got confined gaskets, we can also step in the tube sheet for you as well. But let's keep moving on. So what I'm going to do is click next. And then we've got the tube-to-tube sheet joint calculations that we need to look up. Now we have both the Appendix A calculation method as well as the UHX. So if you decide to go with the UHX, we'll determine the fillet weld size for you based on the sketches that you choose, like so. Or you can choose to do an Appendix A analysis, and I'll take F right here. Okay, and keep in mind, as we're selecting these, we can always come back in and change these inputs afterwards as well. So what we'll do is we'll click next, and then we come to the nozzles page. Now Compress will put an inlet and an outlet nozzle both on the shell side and the tube side for you, and we can also put some auxiliary connections on here as well. Now what I'm going to do is I'm actually going to take these off, and I'm going to show you how we're going to add nozzles on afterwards. So I'll just uncheck them here. Now once I get to this point, what I'm going to do is click Finish. And what this will do is create the exchanger for you, as you see right here. So we can move this around, we can rotate it, things like that. Now what we can do is we can make any edits to this exchanger. So let's say, for example, I want to make my channel cylinder a little bit shorter. Well, what we can do is we can edit this heat exchanger. So what you would do is you would right click on your heat exchanger and you'd select tube sheet. And this is going to open the heat exchanger wizard back up. So you may notice now that all of our pages are tabbed along the top. So for example, if you want to come back in to the design conditions page, maybe we want to add another design condition or we want to modify one of them, we can now make edits to this heat exchanger. But let's say I wanted to make the channel shorter, so I would come to the channel page and I would take a look and say, okay, my channel cylinder length, let's make this 15 inches. And I'll do the same for the rear. Type that in, I can click OK, and as you can see, the channel cylinders have been shortened up a little bit. Okay, so I had mentioned to you that's how we design the heat exchangers in the wizard. But what if we want to start putting some additional information on it? For example, nozzles. Let's put some nozzles on this. Well, we can also do some of the freeform modeling that many of our users are accustomed to. So for example, let's say I want to add a nozzle. Well, what I could do is come up to my nozzle menu. I could select Detailed Design, and we could go through our nozzle dialog. So for example, let's model this as a type 2, so I'll take a nozzle neck with a repad, and we'll leave it as a nozzle, we'll make it radial. Then all we're going to do is specify the drawing mark and the identifier. So this is up to you if it's an inlet or outlet, however you want to name it. And then we'll select the material from the pull-down list, and this is what we've seen before. Same with the pad. Alright, then what I'm going to do is I'm going to drop down to the middle, and I'm going to size my nozzle neck. Now you can type in your own outer diameter, nominal thickness. Typically you would do this if you have a very odd ball nozzle, maybe a 13-inch nozzle or a 17-inch, things like that. What we're going to do is just go to the standard size lookup right here, and we're going to take a 10-inch nozzle, and we're going to start with standard schedule. So I'll click OK, and this information will get pulled across. So at this point, now what I would do is I would add a flange onto this nozzle. And we're going to do that by coming back up here and choosing whether we want to add an ASME B16.5 flange or if we'd like to design one using the Appendix 2 flange analysis. So let's just add a B16.5 flange. So I'll just click on this button here. And this input, just very basic inputs. We just need to know the material, the flange type, and the flange class. So let's take a 300 class flange. We already know what's going on to a 10-inch nozzle, so compressors look that up for us. Now we just need to know some bolting information, like gasket details, and the radiography of how we're going to x-ray the seam once we weld it on. So I'll go ahead and click OK here. And as you can see, the flange has been added on to the end of the nozzle neck. So now what do I need to do? I just need to locate it onto the vessel. That's going to take place down here. Now let's say this was going to be on the front channel. So what I would do is I would select front channel right here. And then I just need to know an offset. So I know the length is 15 inches, so let's put it halfway in the middle. So I'll put it 7.5 inches, and I'll leave it on the top. And then I need to give it a projection distance. Now this distance is going to be taken from the center of the cylinder to the face of the flange. Now if you know this dimension, great. If you don't, no problem. Let's say you get an external projection length. Maybe it needs to project out 9 inches. Well, if you do, what you can do is click on this button below. It says calculate minimum R from desired external projection length, like so. And we can type in our projection. So I'll type in 9 inches, click OK, and we'll calculate this value for you. So this first screen is really just setting up the nozzle. So let's go to the next screen and see if this meets code criteria. So I'll click next. And as you can see, here's a cross-sectional view of the nozzle. So what we'll need to do is first decide, is this meeting code criteria? And what we do is you can come down here and we can look at our status bar. Now, this nozzle is actually being designed currently with the rules of Appendix 1-10. So instead of having the classic area replacement method, we're actually looking at the primary stress and we're going to compare it to the allowable stress. So my primary stress is just under 20,000, but my allowable stress is 30,000. So this is passing code. But one thing we might want to do is say, well, do I even have to have a reinforcing pad? My stress is, well under the allowable. Let's take it off. So I'll click previous, and I can change this back to a type 1. I'm going to click next. And as you can see, my primary stress has increased about 26,000, but I'm still under the allowable stress. Okay. So let's go ahead and click OK here. And as you can see, the nozzle has been added onto the cylinder. Now, one other thing you may notice is that, I've placed it on a longitudinal seam. Well, let's rotate that seam. And how we do that is when we have longitudinal seams on the heat exchanger, a long seams button here will appear. So if I click on this, you can see here's a 2D shell rollout. And we can see right here, I have a longitudinal seam going right through my nozzle. Now, if this is actually how it's going to be constructed, that's fine. We just have to go edit the nozzle, and there's an option there that says the nozzle is through a category A joint. But let's move it. So I'm going to move it based on angular position, and I'm going to move it to 270 degrees. I'll click OK. And as you can see, the seam has been moved. Okay, so that's an overview of the modeling of the heat exchanger. Now, what are some of the other options we have available to us? If you look down the bottom right-hand corner, you'll see here we have Design, US, Div 1 in 2013. This is what we call our status bar. Now, if you right-click on any of these, some options up here. So, for example, I right-click on Design. You'll see here we have a Design mode and a Rating mode. Our Design mode is meant for new construction, new fabrication, and what we'll do is we'll enforce minimum code thicknesses. Now, on the flip side of this, we also have a Rating mode. So, if you'd like to re-rate this exchanger, maybe you're doing some alterations or some repair work, we'll want to put it into Rating mode. And what we'll do is based on the geometry you give us, we'll derate the heat exchanger for you. We also have US customary as well as metric units, Division 1, and then the 2013 is the code edition. Now, if I right-click on this, what compress does is gives you all the previous editions and addendas. Now, we go back to 1995, so if you are doing any re-rates or alterations, you can do them to the original code of construction. Okay, so let's run the code calculations now and take a look at the heat exchanger. So in order to do this, what we'll do is we'll come up to the Action menu, and we'll select Perform Code Calculations right here. Okay, so here's our output report. Now this is being currently viewed in the HTML version. If you click on the PDF icon, we'll switch it over to a PDF. And we can customize our reports. So you can actually remove reports, minimize reports. If you don't want them as long, we can do that. But I'm going to show you a few things in the HTML version. So what we have in their HTML are summary reports here, which just summarize the design. So the deficiency summary, the pressure summary, the radiography summary, hydrostatic test, things like that. So for example, if you were to click on the hydrostatic test, you'll see here are all the components from the heat exchanger, the local test pressure, but more importantly, the stress during tests. So we'll actually calculate the stress for you and compare it to the allowable stress. Likewise, all of the individual components will get their own report. So for example, the front channel, it's a cylinder, so here would be a cylinder report for you. And everything is broken down for you, so you have a full paper trail of how compress is determining all of our values. Now for the tube sheet analysis, they'll be down here at the bottom. So let's click on the ASME tube sheet report right here. Now one thing we can do with our tube sheet reports is that if we click on the heading right here, we can suppress the reports for you. So this makes it a lot easier to scroll through. So for example, I want to take a look at the design thickness summary or the pressures. So we can minimize them, expand them, things like that. But let's take a look at the calculations of the operating condition. So what we do is we lay out every step from UHX 13 because this is a fixed exchanger. What we'll do is we'll lay out all the formulas that we use. And then what we do is down below are all the calculations with the values. So you have a full paper trail of what compress is doing. So if you'd like to investigate something, again, you can just minimize these. Maybe you want to come to step 9 and look into it a little bit further. So as you can see, we've run through all the different load cases for you with all the values. So this makes it a lot easier to backtrack if you're trying to investigate anything. So let's say we're in this report and we want to switch back to the model. We want to go and make some changes. Maybe we want to try to drop the tube sheet thickness or increase it, see what that does. Well, when we're in the reports, what you'll do is you'll click on the HTML icon, since we're in the HTML report, like so, and we come back to the model. Okay, so we've touched on the modeling aspect as well as the calculations. Now let's fill out some of those forms. So when we build these heat exchangers, we need to fill out our U forms. And Compress can do this for you automatically. So what we would do is we'd simply come up to our forms menu and we'd select an ASME U form. So what we would do is scroll across, come down here and select ASME U5 form. What this will do is open up an HTML version of this form, and Compress will fill out all the information for you. So as you can see, here's our form. And the information here at the top is actually your information. So you can actually fill this out in a default setting so that every time you generate a form, this information will come up. Then all the technical information from the vessel will be populated for you from Compress. So you can scroll through, review it, and then when you're happy with it, you can click Finished, and Compress will generate a PDF report of this form. Like so. So we can print this off, mail it into the board, things like that. I'd like to thank you for watching this heat exchanger demonstration. If you have any questions about Compress or you'd like to see a demonstration, please email sales@codeware.com or give us a call at 941-927-2670.